Hey everyone, what is happening? Well, we're going to be talking a little bit about half-life. Now, it's just like it says, half-life. First, we're going to talk about carbon dating. Now, we can measure how much radioactivity in a plant or animal remains has changed over time, and we can calculate the age of those remains. All right, so all organisms on Earth contain carbon. And carbon is really cool because it includes C12, which is an isotope, and C14. And remember, we talked about isotopes, and there are different versions of the same element. So when a plant or animal is alive, the amounts of C12 and C14 stay the same. Right? They have a certain ratio, and they just stay that way when you're alive. But after the organism dies, the C14 atoms start to decay and they're not replaced, and that gives us an indication of how old something is. Now, by comparing the amount of C12 with C14, the age of the remains is estimated. So radiocarbon dating is the process of determining the age of an object by measuring the amount of C14 remaining in the object. However, only plants and animals that have lived within about the last 50,000 years contain enough carbon-14 to be measured. Now you're going to see this in our graph that there's only that age limit can be tested because otherwise there's just not enough C14 to even see it. And that leads us to the rate of radioactive decay. Now, the half-life of an isotope is the time needed for half of the nuclei in a sample to decay. I want you to think about cookies here. All right? If the half-life of cookies is 10 minutes. So if you start with 10 cookies, and in 10 minutes, that means half will be gone. All right, so in 10 minutes, you'll have 5. In another 10 minutes, you'll have 2.5. In the next 10 minutes, you'll have 1.25 cookies left. So half an hour, you only have 1.25 cookies left. And this is the same for several different isotopes, or radioactive isotopes. So the half-life of strontium-90 is 29 years. That means it takes 29 years for half of it to be broken down. So if you have 10 grams of strontium-90, now you'll have 5 grams left after 29 years have passed. Sometimes information about radioactive decay can be displayed on a decay curve. And this is really cool because it looks exactly the same for every single radioisotope. So the decay curve is a graph that shows the rate at which radioisotopes decay. Here's the decay curve for strontium-90. All right, so you'll look at here on the left-hand side, we've got a percentage of strontium-90. We always start at 100. All right. Next, we've got half-lives. Half-lives, they depend on what element it is. For strontium-90, it's 29 years. It could be 8 days for some elements. It could be 2.3 million years for other elements. And you'll notice after one half-life, we have 50%. After 2 half-lives, we have 25% because we cut each one in half every time. And that goes on all the way down to basically when there's nothing left. All radioisotopes have decay curves that look kind of like the strontium-90 one. We talked about this. The only difference will be the length of the half-life, since all radioisotopes have their own half-life. So let's look at iodine-131 as an example. And it's an isotope used in the treatment of thyroid cancer. Now, it has a half-life of 8 days, very, very short. So if you start out with 25 grams of iodine-131, how much will you have left after 8 days? Well, what we're going to do is we're going to put our beginning amount, and we're going to multiply it by a half. What that does really is it divides it by 2, and we get, after 8 days, 12.5 grams of iodine-131 left. Now, after 16 days, we start again with our 25 grams. And we're going to multiply it by 1/2, which is 8 days. And then another half-life, which is another 8 days, and that equals 16. And we get 6.25 grams left after 16 days. Now, you'll start to see a pattern here. Every single time we start with the total number, or the 100% that we started with. And 32 days, well, 32 divided by 8 equals 4. So we have 4 half-lives. So we're going to multiply it by 4 halves. And we get, and really what you're saying is 25 divided by what is 2 times 2 times 2 times 2, which is 16, and we get 1.56 grams left after 32 days. Next we have 64 days, and we go 64 divided by the half-life of 8, which is 8 half-lives. Alright, so what that says is we're going to start with 25 grams again, and we're going to multiply it by 8 halves. And we get a very small number is left, and we get 0.097 grams. Alright, so what you can start to notice is each half-life is an independent event. So you start with a certain amount, you cut it in half after a half-life, and then that new amount you cut in half again. Alright, the mass of the radioisotope is reduced by half after each half-life passes. And we're going to get more work on this in class, but I would like you to turn the page, and I'd like you to try looking at these few questions, these 4 questions, for carbon 14. Have a good rest of the day.